Thank you. Glad I didn't speak too long without audio. Um, Luckily, you didn't miss too much or anything really. So today we are going to do a quick recap of yesterday, and then we are going to jump into circuits, and then we are going to see how we can turn those circuits into printed circuit boards that we can then order. So, just going to take some quick notes real quick. So I like to keep notes in my stream. On that note, if you notice anything that I could do better, there's a little feedback form down below. I would appreciate if you filled it out so I can improve on the things that I do for y'all. So yesterday, we talked about what an Arduino is. Let's see, we can just, no. Let's open up the day one presentation notes. Cool, so we talked about kind of what an Arduino is, and we'll kind of revisit that talk today. We looked at it through the context of just programming, talked about resources, and ran through some code examples, and then left off with some homework assignments, which we posted about in Slack. And so these are all recorded already on YouTube. You can check them out. Link down below to social media. You can check out my YouTube page where these will all be recorded and posted. And you can find the full summary and the full recording of day one there. So, on to day two. For those that have joined yesterday, we're going to repeat ourselves a little bit just because each day might be focused on some different people. So bear with me for the first few slides and then we'll dive into the meat of things. So, about me. My name's Travis. You can get my email there. Feel free to contact me about stuff related to CAD code and circuitry. I have a Bachelor's of Science in Mechanical Engineering, and I held an internship for about a year doing mechanical design, so CAD, design for manufacturing, 3D printing, that kind of stuff. From there, I moved on to decided to teach myself software engineering, and so now I'm a full-time software engineer building websites, and then kind of along the way decided that I wanted to learn how circuit boards were made, built a circuit board that I thought could make me some money, and so I launched a little electrical engineering startup that eventually failed, but did get to create a circuit board out of it. So that's a bit about me. And a quick plug, if you have questions at any time about anything related to the topics, please let me know. Glad to answer them. Glad to go on tangents. There might be things that I didn't quite cover in these slides that you might find interesting, might find relevant. Others might find interesting and relevant as well. So please do ask questions as we are going. And I'll try and give pauses as we're going to answer them. I'll also keep an eye on preferably Slack so we can have a better conversation going, but also be keeping an eye on Twitch chat for your questions. Cool. All right, so the goal of today is not to, or let's say what the goal of today is. It's to learn about the unknown unknowns, the things that you might not know in your education, and how you can take your next steps. Today we'll kind of give you a map and idea so that you can choose your own adventure. This is not going to be everything you need to know about circuits because literally people get full-time jobs and spend entire careers learning, building, producing, manufacturing circuits. But this will hopefully get you on the road to building cool stuff for personal projects, or maybe if you want to switch careers or things like that. So the journey, it will not be hard, but it'll be worth it. About 4 years ago, I knew nothing that I'm talking to you about now besides the mechanical engineering bit. And even then, didn't know Fusion 360, which is the CAD software we'll use on Thursday. So taught myself programming, taught myself circuitry design and things like that. Love learning, love building, love sharing. And I've kind of documented that process of what I've kind of coined learning to learn. And you can check that link out there on my blog. The slides for today are linked down below, and you can also find all the resources at painlessprototyping.com if you can't find them here. Cool. So what is an Arduino? And I'm kind of going to be jumping back and forth a little bit between this side and this photo. So this is an Arduino. This is a soil moisture sensor, a little device that you can plug these little prongs into soil, and then you can measure how moist the soil is so you know when to water your garden or not. So the Arduino is a device that you can, on your computer, you can write code, and then you can take that code and you can send it to this little device. Excuse me. And then you can connect the physical world to this device. So you can connect sensors, like the moisture sensor that we have here. You can connect lights, you can connect buttons, anything that you can interact with that is involved in a circuit, you can connect to an Arduino. Arduino is super widespread, so you can do lots of cool projects with it. You can find tutorials and all these different kind of things. And so this is one such thing that we can connect to a soil or to an Arduino. So this is a sensor, and basically up here, the way that you connect things to an Arduino, and we'll go more into this later, is that you just run wires to these holes here, and then connect them to these holes here, and then you can say that it's kind of upside down, but like this number 10 here, you can say number 10 is a soil moisture sensor, and then you can write some code that'll receive that in the soil moisture sensor, and then maybe you could output it to your computer or send a text message that says your garden's dry, go water it. Or you could even wire it up to a water pump that the Arduino could control, that when your soil is not moist enough, turn on the pump, send it out. And it's really not that many lines of code to do such a thing. So if we wanted to switch to, let's go to Tinkercad. Why does it think I'm on mobile? Cool. So we'll come back to all this in a second. I just want a place to write some text. I'm clicking on all the wrong things. Oh, that's why. Okay. Sorry. Well, bear with me one moment. Okay. So for those that know code, and if you don't know, we'll go back over kind of bits from yesterday. So we'll say that in our setup, we'll say that maybe pin. So here's our Arduino, and like pin 10, as I mentioned, is an input. Actually, we won't go through all this. We'll just go through the loop. So if so this is almost the entirety of the code that you need to measure a soil sensor, or use a soil sensor and then water your garden. So really it's a loop. It continues forever, and it'll walk one line at a time. And the first one we'll measure the soil moisture, and it'll return a true or false value. So is dry will either be true or false, and if it is dry, we will turn on the pump. We will wait 10 seconds. Sorry. Delay takes an argument of milliseconds, so 1,000 milliseconds is 1 second. Multiply that by 10 gives us 10 seconds, and then we'll turn off the pump. And there's so many helper libraries and code and tutorials and things out there that you really don't have to write all this code yourself, which is why this is so awesome. And this really might be, I'd say, probably 4 or 5 more lines of code, and you could have an automatic plant water system. It's like super simple. So I'm not sure if I rushed through that too quickly. If there are any questions, please pop them in chat. I'm going to take a quick sip of my drink. continue on. All right, so that's kind of what an Arduino is. And then there are so many sensors. There's sensors for all kind of things in the physical world that you'd want to sense. Light, temperature, different kinds of gas, uh, time of day, moisture, alcohol content. You can have outputs as well. So sensors are kind of the inputs. They give you information in your system. And then you can outputs. So you can have lights, and you can have motors, and screens, and just tons of different things. And you can connect them all up to the Arduino. And there are tutorials for everything, which is why it's so awesome. So say you want to connect an LED and a button. You go read how a button works. You get a nice little tutorial. Read about an LED. You get a nice little tutorial, and then you can figure out how to press the button to turn on the LED, because you can just put the two example tutorials together. And that's why I really love Arduino, because the environment, the community is just so awesome. Cool. So speaking of community, here are a list of resources. Arduino is like the official website, so you can go to arduino.cc. SparkFun and Adafruit sell a ton of components and also have lots of great tutorials and things like that. Two of my favorite websites to buy stuff. Khan Academy for if you're feeling a little rusty on your math, science, and engineering. We're not going to go too deep into things today, and honestly, you don't really need that much math, science, and engineering to get started. Probably stuff you forgot from high school math, or maybe middle school math is like really all the math that you need. If you want to start building crazy complicated circuits, maybe you'll need a little bit more math, but like I just last week actually bought the components to make more complicated circuits, and I've been building circuits for like 2 or 3 years now, and I've been able to get by with just super simple stuff that you can really kind of connect together like Legos, super simple. But if you want refreshers, Khan Academy is a great place to do that, and then also Adafruit and SparkFun, and then Tinkercad, which I just discovered while I was preparing for these courses, is a great place to go as well. Cool. So, little preface on safety, security, that kind of thing. Super important. And sorry, for whatever reason, my nose itches a lot when I stream, so I'm going to keep itching my nose. Hopefully, I don't keep tapping the microphone. So, electricity is dangerous, and I think everyone here knows that. These little... So we'll jump into this kit that I'd suggest people purchase, but this is basically kind of the starter kit that you get. So you get like an Arduino, you get some LEDs, some wires, and things like that. You cannot really... I mean, you can, and you can probably find a way to harm yourself with this thing. But for the most part, with the intro stuff, you're never really going to find yourself dealing with dangerous levels of electricity, because you'll keep it plugged in your computer. If you start plugging this Arduino thing into the wall, be careful then. But if you're plugging it directly with the US cable and B cable into your computer, then you're generally fine. Don't wire your oven, your dryer, your front door locks, etc. to your Arduino without knowing what you're doing. Even to this day, with the amount of experience I have, I will not do these things. Maybe there's some device that you can buy off the shelf for $40 to, I don't know, do some fancy thing with your oven, or you could wire it up yourself for free with an Arduino. If you burn your house down, you're much more likely to get a good go of insurance with the thing you bought off the shelf, which was regulated by all the regulating bodies and things, versus if you burn your house down because you accidentally wire some things up with an Arduino and you don't have electrical engineering or electrician experience. Don't do dumb stuff. Be smart about it. Yeah, if you get to dealing with like really large batteries or other things, like, be safe. And maybe go find an electrician or an electrical engineering person to, if you're ever in doubt, ask somebody. Yeah, that's about all I'm going to say on that. Any questions? Did I freak anyone out with any of my statements? Hopefully I didn't. All right. Everything's okay, Law Tip says. Awesome. Okay. So we are going to focus a bit on the Arduino and a bit on Tinkercad. So maybe we'll just do them split screen side by side. We'll close this out. Okay. All right, let's just start with the Arduino. So this is the Arduino software. You can download it from arduino.cc. Actually, let's do these side by side because you'll notice some similarities between things. Why do circuits? Oh man, this view is hard to reason about. There we go. Okay, cool. So if you come over into Tinkercad, and just to kind of get everyone on the same page, if you scroll down to the bottom and you select Arduino and you click it and you drag it up, you now have like a little environment with an Arduino in it. Whereas we're going to switch over to screen and desk view. If we come over here with our Arduino kit, we're going to start out with the Arduino, and we have our cable. And I actually want to grab a longer cable off the shelf because this blue one doesn't reach around to my computer. Oh, I think this is the cable I need. Cool. So same cable, just longer. And for those following along at home with an Arduino, you can go ahead and plug it into your computer. All right, so plugged it in. We got a green little light, so we're good to go with our Arduino. Okay, so at this point, if we come over into Tinkercad, and basically how I'm going to kind of try to do this is that we'll get to a point where you can do either operation with either software. So if you're using Tinkercad, we'll be good to go. If you're doing Arduino on the desk with the Arduino software, you're also good to go. So yeah, so at this point, to finish out with the connection of the Arduino, when you plug in a new Arduino, you always need to come over to Tools, your board, and select the board that you have. And it's recommended that you have Uno. If you have another board, you should probably know how to set that one up. So you select your Uno, and then you come over to Tools, Port, and these are kind of, port stands for USB port, and so COM is a communication device that is connected to your computer. So other things like keyboards and mice might also show up in this list. Sometimes when you're debugging and having issues, it might be because you selected the wrong port. Luckily for the Arduino that I've purchased, it is nice enough to display that it is indeed an Arduino. And last step to check that everything is running is we like to do the example basic blink sketch, which will actually talk through and write, but to make sure that everyone's on the same page, if you come up to File, Examples, and then Basics, you can select Blink from the drop-down menu. And we'll pull this up here, and then if you hit the right arrow in the menu to upload, we'll see some steps happen down below, and if everything goes correctly, you'll see a bunch of flashing lights on the LED, during which time the code gets uploaded, and now we can see that this LED here is blinking. And so this is kind of just to make sure that we can write code, we can upload it, we can send it to the Arduino. So at this point, we are good to go with Arduino, the physical Arduino. I'm going to try and refer to the right side of the screen as Arduino and the left side as Tinkercad, if I can hopefully not mix myself up. All right, so on the left side, we want to come over, and now that we've dragged our Arduino in, we want to click on Code, click on the drop down here and change it to Text, and we'll hit Continue. And this will give us the same code. So if I scroll down on the right side, you'll see that this code is more or less the same. It has a setup bit, which we have over here. We have a pin mode where we declare something. Here it's 13, here it's LED built in, but both of them outputs. And then we have this digital write, delay, digital write, delay. And so we'll go through all this stuff, but same code basically on the right and left side. I think I can actually just copy this code over, paste it here, and run it as well. So to execute this code, you can hit Start Simulation. And if we close the code and we zoom in on the Arduino, we can see that we have a virtually blinking LED. So if anyone has gotten stuck up to this point, please feel free to post in chat, and I will be happy to get everyone up to speed. This is always, there are a lot of steps that I just went over very quickly. And you might have some issues of your own. So I'll sit here and I'll just create some issues of my own while I wait to see if anyone in chat has any problems. So one thing you can do is maybe you specify the wrong ports. Maybe I didn't know the COM, so I select COM1. And if I come over here and I hit upload, it looks like it's struggling and something's happening. I never read any of the text up here, by the way. Okay, so whatever that COM1 is actually giving the Arduino a good run for its money. All right, so let's see. So maybe we could debug this. We can be like, Arduino is stuck uploading. And so Googling, you can come over here and you can kind of read through issues that people have. And so keep reading until you find things that might be an issue. And so one of the ways I actually would have probably debugged this, since I'm not sure what's happening here, is there we go. An error occurred while uploading the sketch. Is it just going to keep erroring? Okay. Interesting. So I might see, one thing I might do to debug this is I'll take my Arduino, I'll disconnect it, I'll come back to this list and go to the list, and you'll see that there used to be COM1 and COM10, and now there's just COM1. So when I plug it back in and I come down to Tools, Ports, you see COM1 and COM10. So now if it didn't have the little descriptor Arduino Uno on it, maybe that's it. I can also try moving the Arduino around to different USB ports. You can try and change the board, maybe have the wrong board selected, things like that. It could also be that you're uploading bad code or code with errors in it. And so you can always just come to File, New as a little sanity check and upload this code, which is just the bare minimum, should work. And oh, look, we're getting errors. Interesting. Okay, let's debug why this is happening. So Tools, the board is correct, the port is correct. It looks like that's a lie. Weird. Okay, so sometimes the errors are flukes, they're fake. So it looks like what happened there. So hit upload again, and it uploaded. And you'll get used to this over time of just kind of hitting the knobs and dials and figuring out what works to make it upload. Trust me, it used to be a lot worse than this debugging, so we've come a long way. Sorry, just like silence my phone real quick. Sorry about that. Okay, cool. All right. So we have blinking LEDs in both. And for now, we'll kind of just focus on the Arduino text editor because we actually covered the Tinkercad stuff yesterday, and we'll kind of just write our code in Arduino. If you're following along with Tinkercad, feel free to toss me any questions. When we actually start wiring up circuits, we'll come back to Tinkercad because it's actually easier to visualize things. Okay, so we've covered the main bits that one should know. You can jump through other menus and things. Examples, as I'd mentioned, there's lots of examples in the Arduino community, so you can come through here and you can find everything for all the different things you might want. And you actually go out to the internet and get your own examples as well. If you find some piece of hardware that you install which doesn't have an example for, you can probably just Google it and you can find an example for it, and we will get to that a bit later. Cool. So we're going to learn, we're going to do our first sketch, and we're going to make an LED blink. So let's start with the new, let's delete everything in here, and we'll start here. So, where to begin? So we are going to do what is called the blink sketch. The blink sketch, so sketches are kind of where you write your code in Arduino. We're going to switch back over just to screen. Perfect. Excuse me. So we are going to write a program, or sorry, the blinky sketch is the most introductory way of doing Arduino. In the programming world, it's the quickest way you can write hello world, get it output to the screen. In the Arduino world, it's the quickest way to make an LED blink. So what we want to do is set this up to use an LED. And as we'd already I'd hinted to before, each Arduino has a built-in LED on it. So we can control that LED with LED built in. I think that's what it's called. LED underscore built in. Okay, cool. So each Arduino out there has a built-in LED that you can control to kind of begin your journey. You can use it for debugging and testing and that kind of stuff. And so an LED is a thing that we want to output to. We want to control it, whereas a button we'd want to receive information from, or a sensor we'd want to receive information from. So the first thing we do is our setup called pin mode. And each of the pins, let's close out, close the sidebar. Nope, okay. So this is the actual physical bits of the Arduino. And the Arduino has these things called pins, which you can see are being marked as I hover over. And these are where we connect our wires and things from external other components that we want to connect to our board. So we want to put wires into here. And we can do that with what are called jumper wires. We can see just what jumper wires look like here. It's just a pin here that you can put into your Arduino, and then another pin which you connect to the little component you want to connect it to. And there's different kinds of jumper wires. So you can see this have pins on one side, so you can plug in stuff on the other side. And so the built-in LED, we don't need to use any pins, but it's still connected to a pin. And for the Arduino Uno specifically, it's connected to 13. So this is 13, but also the onboard LED here is 13 as well. So we'll set our pin mode, and we want to say that pin mode LED built in is an output. And we always end our sentences in programming with a semicolon in C++. We could also do pin mode 13 output, and that would give you the same thing. Or we could do onboard LED equals 13, do pin mode output, and that also give you the same thing. So these are all equivalent. So let's we'll keep the LED built in for now. Cool. And then, since we are outputting to it, we want to send something to it. And so there are two states or conditions that an LED can be in. It can be on or it can be off. So in the Arduino world, on is referred to as high, and off is referred to as low. And case matters, by the way, so things need to be uppercase specifically for here. See is where this is different, and that's just something to keep in mind. Different things are cased different ways. So to control an LED, we'll want to do digital write. So this actually introduces us to a new thing. So there's two ways. There's digital write and there's analog write. And so digital write, so an LED can just be on or off. It's only two states. And so that's kind of this idea of digital, where it can just be on or it can be off. Whereas if you think about with like a temperature sensor, you could get any value from negative whatever to positive whatever, and there's lots of different values. Like an LED is just on or off, whereas a temperature sensor could be any which way. And so we won't go into it today, but you use your analog pins to measure those kind of more real life kind of things. So intensity of light, uh, things like that. Whereas you use your digital pins for like motors, like a motor is either on or off, things like that. So that's kind of the basics of digital versus analog, and you'll see that digital take up more pins, whereas analog only takes up 1, 2, 3, 4, 5, 6. The other side, it takes up 14, 0 to 13. We'll go into the other pins as we start connect things to the board, but that's the general of it. And so we want a digital write. I'll take a quick breather to see if there are any questions. Cool. All right, so we will continue on. All right, so now that we've set our LED built-in as an output, where we're going to want to actually write some things to it. So LED built-in, we're going to output high. And actually, I think this code is better off over in Tinkercad. So I'm just going to copy it. I'm going to paste it in here. And it's not the best way to zoom in on text, which is a bit of a bummer. Okay, I'm going to do a little sneaky thing real quick. Let's see if I can get away with this. I don't think so. When I can't change things in the browser, I go and do it myself. Okay. I hope this doesn't change as I start to write more things. Awesome. Okay. So I don't have to hit ++ in my browser. Oh no. Let's try that one more time. Oh, it's still there. It's just I have to increase this one. Let's go. Oh, that's a bummer. Okay, I'll stop mucking around. Okay, so we'll come back to code. We'll ++, so hopefully that's legible. If y'all can't see that, please let me know. All right, so we'll move over to our onboard LED that we have here. All right, so if we start the simulation, what did I do? Void loop. Error expected. Expected semicolon before the curly. Okay, it's actually helpful. So we need a semicolon here before the curly. All right, so we should see the LED turn on. If we comment out this line, run it again. What? I'm very confused. I wonder if that's always going to turn on. Oh, okay, I might be looking at the wrong pin. Or the wrong LED. I think that just means power. Okay, let's maybe look at these ones. There we go. Okay, so I was looking at the wrong thing. Man, I had a quick little confusion there. All right. So real quick, I want to just take a quick tangent. Because because this actually highlights an interesting issue. Is you can Google Arduino board diagrams, and I didn't prepare for this, so hopefully I can find. Actually, this is a perfect photo here. So we look at this Arduino sketch here. So I was looking at this LED here, and we can actually read here that it says this is the on indication LED. So O1 on, just the word on, indicates that the board is receiving power. And so this doesn't actually diagram what this L is over here, or the RTX and the TX and other things on here. So maybe we'll look at a different, maybe more. Yes, you'll sometimes find that not every board is diagrammed with all the things you need, so sometimes you have to jump around. But this second board is well diagrammed. If we come and look at this, we can scroll down, and we can see on this one that this is actually the pin 13 LED, or the onboard LED that I'd specified. And so it gives you a little indicator of that. It talks about a bunch of other things that we don't really need as well. But when you're unsure of what something does on a board, it's always helpful to pull up these diagrams and kind of read through them. And even if you don't understand what's here, at least you'll have a name for things. So this is very not descriptive, but you could maybe take pin 13 LED to Google and see what's going on there. So I wonder if actually we would type that in. And look, you could read all about the pin 13 LED and things like that. So Google's your friend. Google often. Take notes, that kind of thing. All right, so we got that. Well, now, how do we make the LED blink? So at some point, we're going to need to turn it off. So what is an LED blinking? It's turning on, it's waiting, it's turning off, and it's just repeating that. So we can do delay, and this function takes milliseconds, so 500 milliseconds makes up half a second, and we can run this, and then we can repeat this previous command, but this time we can turn it low. All right, so we'll see what happens. So LED turns on. Wrong one. This one over here. Let's zoom in on it. So this one just stays on. Now, why might that be? If anyone has any ideas in chat, I'll let you answer. Otherwise, I'm going to take a sip of drink and I'll answer. Okay, so what's happening here, and this is another little gotcha, is Hellcat asks, what's the question? Why does the LED here stay on always, even though we turned it off? Cool, so I'm going to, let's see. Maxito says, delay too big. And Hellcat asks, is it a loop? It is indeed a loop. So this loop here says that, so basically what this code is saying is this is the initial setup, and then this loop will run over and over and over again until you unplug the Arduino. Is the delay too big? So we could check that. So let's make it really small. If we make it a 1, which is, I believe, as small as it can be, it still stays on. And we could even come and double check the documentation for delay, and we see that it pauses the program for the amount of time in milliseconds specified as a parameter. So the number of milliseconds to pause, and so that's basically what that does. The answer was on that page, and that's why I closed it really quickly. All right, so we changed the delay value, and that didn't do anything. What else might we try? So don't worry, I'm pausing here because I still actually do this, and I don't know why it's so hard to reason about. Um, so what the issue is that if we think through this kind of like line by line, we turn the LED on, we wait half a second, we turn it off, we're out of instructions, so we come back to the top, we immediately turn it back on. So there is a very, very, very small period of time during which it is off. And it's actually not even off long enough for us to even notice because computer instructions are very, very fast. And so, yeah, we will add another delay. So we throw that in there. We can now start. And we have a blinking LED. Cool. So I'll copy this code real quick and I will throw it into Slack. Cool. So any questions up to here? Cool. Okay. So this is how we make an LED blink. We've covered pin modes and digital writes and analog writes and delays and that kind of thing. I'm going to peek real quick ahead. Okay. So we're going to do next step. I lost myself. Okay. So say we want to wire up a push button. So a button is something that just... Actually, let's redo this sketch real quick before we jump into buttons and see how we can start to wire up an LED. So here's actually the tutorial that you can find kind of how to do the blink. And so this tutorial talks about the LED built-in that we had just discussed, where you might find it on all the various different Arduinos. But we want to start to do some interesting things. We don't want to just use the built-in Arduino. We want to use, the built-in LED. We want to use our own LEDs and connect them ourselves. So if we come here, in this tutorial there's a parts list where it has an LED and a 220 ohm resistor. And it looks like here is how we can connect it together. So the blue bit are wires, and then we'll connect the wires to the LEDs, and then the LED to the resistor. And that's how we can kind of actually start to set up our own LEDs and control them. So if we come back here, we can close our code for now, and we're going to want to grab our LED. So we'll drag that over. We can pick a color. I like blue, so I'm going to go blue. We can drag in a resistor. And here, it asks for a value of resistance. And if we come back over to our tutorial, it says the value of the resistor, or let's go back to the top. It's a 220 ohm resistor. Whoop. So we'll come over here, and you'll notice all these weird symbols. And these are, I'll just quickly say that they're measures of the metric system. So this thing that looks like a horseshoe, the shape here, is called an ohm, and this is how resistance is measured. But you have these other values, milliohm, microohm, nanoohm, picoohm, kiloohm, megaohm, gigaohm. And you might actually mention or notice some of those prefixes. So milli, as in like millimeter, or kilo, as in kilogram, or in mega, as in megabyte, giga, as in gigabyte. And so these are all the metric prefixes. We're just going to go with the regular old ohm because that's what it told us to do, and we'll do 220 ohms. Oh, that's interesting. So, random little fun fact about resistors is these color codes here actually mean something. There's the whole chart on how to measure resistors, and I still don't have any idea how to do this. If you get out, you can get a device that's called a multimeter, which will just give you a little display with the actual value of the resistor, or resistors comes packed together. So like if we look at our, so what I have in the kit that I'd mentioned is you get these little kits, and you can see that like this is, you can see this says 10K, so that's 10 kilo ohms. It has little stripes on it. I'm not going to bother to measure those. But what I noticed in here is this software is actually pretty cool, is as you change these values, the colors change to other things. So maybe a fun little way to learn your colors of your resistors. But 220 is what we want. And if we come back and look at that, it looks like ground goes up to one side of the Arduino, and then this weird squiggly bit comes down to the resistor to 13. Oh, show screen. Sorry about that. So this is what we're going to try and recreate here. And this brings up an interesting point, is that electricity always flows. Electricity is kind of like a waterfall. It always starts high and then it ends low. So we can think of every circuit is generally, actually let's bring up sketchbook. Just going to grab my sketchbook from underneath my desk. Just give me one moment while I also grab my pen. Which I did put it back where I had it before. Sorry about that. Okay. So we're going to go just a little bit of intro to some electrical concepts. So every circuit is made up of volts, which is V, resistance, which is measured in ohms, and current, which is measured in I. And actually, I don't know most of these things. The only time I ever actually really encounter this stuff is with LEDs. But it's kind of one of those things that you learn and then you might have to deal with at some point. But yeah. So some basic things: volts, resistance, and current. And so in every circuit, we start at the high. And so if we imagine, like, here's our waterfall. Terrible looking waterfall. Our equivalent would be at the top. We start out, and these are traditional kind of symbols that we use, 5 volts. So the Arduino can either run at 5 volts or 3.3 volts, or other volts as well, but these are kind of the most popular ones. And we'll ignore even 3.3 volts for now. So 5 volts. And then imagine here's your entire circuit, a whole bunch of stuff. We'll maybe make that look a little more interesting. And then it finishes here, which we call ground. So that's one other thing. And ground usually looks like this, or it looks like GND. So we can come back over to our Arduino here, and we can actually see that GND is ground, and then that 3.3 volts I mentioned is here, 5 volts is here. The next 2 pins are ground. VN, which we won't talk about today, but V can stand for volts. And those are kind of how we move power about our board, electricity. And so every sketch, as I said, starts at 5 volts and goes to ground, or every circuit starts at 5 volts and goes to ground. So if we come back here, we can see that it looks like this resistor that we have here, which is connected to pin 13, the 5 volts will start here, it'll flow up through the LED, and then back down into ground. And so that's how we will do our sketch. So we'll take 5 volts. We will go down into our, let's just draw it sideways, our LED, down through our resistor. This is terribly drawn. And then that will go to ground. All right, so this is ugly. So we're going to make a little quick introduction to circuit schematic designs. And then the electricity kind of, and then we kind of draw like a little arrow here that says that, like, this is our loop. This is how electricity goes. So we'll switch back over, and we're going to take a quick peek into schematics. And you can find this lovely little write-up on SparkFun, how to read a schematic. I'll actually just post this link real quick into Slack. And this is how we can begin to draw a nicer diagram that is easier to read. So if we look here, we'll notice some things that are of interest. We want to use a resistor, so this is how you draw a resistor. We want to draw an LED. So if we look over here, we can see these are how you draw LEDs. We want to draw 5 volts, so we can see that it's this symbol here, and then we want to draw ground, which is one of these symbols over here. So, whoop, wrong window. All right, so if we come back over to our sketch, delete all that terribleness that we wrote. If we wanted to rewrite, actually, we'll come back over here and we'll draw it next to it. Okay, so a more elegant way to write this than to draw these weird little things like this is we can do, we'll start with our 5 volts. So we'll do a little arrow up, draw 5 volts. We will then connect one side of the 5 volts, we'll connect to the LED. And so the LED is this triangle-y looking bit with a line, with arrows coming off to say that it is emitting light. And then we'll, just for kind of, ease of understanding, I'll do a little note that says like blue. Cool. And then from there, we'll want to go to our resistor. So we'll draw a little wire out, draw some squigglies, draw that down. And that resistor is going to be 220. Oh, that's not 220. 220 ohms. And then that will go to ground. And because these symbols are standard across all circuit projects, you generally don't have to draw like the arrows off. You don't have to draw that it's ground. You probably want to specify that it's 5 volts, but you can start to simplify things. Latib asks, resistor doesn't come first. Resistors can go before or after, actually. I'm not going to attempt to explain why, because I truly actually don't understand myself. I think it's the comparisons that I've seen are that you can kind of think there are a lot of similarities between water in a hose and resistance. If you think about like so resistance is basically the act of reducing the amount of electricity that is flowing through, like the energy, the oomph that it has. And so you can apply the same to a hose. So no matter wherever you kind of squeeze it, you still end up getting the same. In that area, it reduces, and overall, it'll reduce. Kind of rambling. I don't quite know, but basically, you can go before or after. Hopefully, that sort of made sense. I think electrical circuits is probably of all the things that I'm teaching, my greatest weakness, and that's why I actually bought a bunch of components to learn how to start building these more complex things so I can understand the math and the science and the electrical stuff behind it. So hopefully, actually, after my next project, I will understand a lot more about such things, but to be seen. So let's see if they, yes. So now that we have this little introduction, we can actually, so you can see that this is one way to diagram things, or we can actually come down here And this giant block here is the representation of an Arduino, and you can see it kind of looks the same as what we had done, that like bird's eye view of the Arduino. You have your analog ports, and then you have all your digital ports, or digital pins, sorry, I should say. You have ground and things like that. And then you can see that, oh, hey, this little squiggly line, we know that. That means a resistor. And this triangular whatever bit, whatever this symbol is an LED. Um, and so that's the introduction to your first schematic. And see if we can't find like, so you look at something crazy like this as an example, and you're like, oh man, that looks like a lot. But you can kind of just start to break it all down. So we know all these squiggly things are resistors, and we know what their values are. We know that this is an LED. This thing here kind of looks like an Arduino, but it's not, and it looks like it has some kind of code, the LM555C. So maybe we throw that into Google, and oh look, we get a whole tutorial on what it is. I usually like to throw Arduino in front of things like this just to get simplified circuits and descriptions. But oh hey, we can read about what an LM555 is, and it'll give you a bunch of information and things like that. And I think I totally lost my tab. I have too many tabs open at this point. We're back. Okay. We could also be like, what's this thing here? And so it's got like what? A long line, a short line, a long line, a short line. So if we come back here and we look through this chart, oh hey, long line, short line is a battery. And so you can go through piece by piece, and you can start to kind of understand what all these things are. Maybe you got this bit out here that it looks like it even says helpfully camera jack. So I suspect that this is a circuit to somehow connect to a camera to do something interesting like that. And if I peek into the URL, I actually see that this is a schematic for doing time-lapse photography to control the camera. So, but yeah, if you break things down piece by piece, they start to become easier to understand. So let's close out of all the windows that we made. Cool. So this is the schematic for what we want to build. And so finally, we can come back here. I just went over a bunch of things and a few tangents. If there are any questions, please throw them in chat. I'm going to take a quick pause for a drink. I'm actually going to grab my water as well. Cool. Looking at the clock, we are actually at break time. So if y'all want to take a 10-minute break, I'm going to open up my little thing where I track the breaks and see, we'll say that we will be back at 13:10. If you have any questions, feel free to throw them in chat. And so we are going to throw our countdown on, and we will say resuming. Whoop. So we'll be back in 10 minutes. I'll stick around though. If you have any questions, feel free to throw them in chat, and I'll give you some answers. Sorry about that. Slightly delayed. Alright, so let's bring myself back up. Cool, we are back. Alright, so we were just picking up where we were going to connect the LEDs and wire it all up. Alright, so we are going to do that. We can click on either side and drag things around, and we get lovely little descriptions. And so one thing to note with LEDs, if we come over, oh, we lost our basic LED bit. Anyway, we can just research this ourselves. So you can see that it's saying the cathode and the anode side. So we come and learn about cathode and anode, and it's probably a complicated term. You'll get a complicated description if you don't throw on Arduino. So always recommend doing that. So we'll come see what they have to say about cathodes and anodes. Maybe not that. Look at definitions. Those feel a little bit more in depth. All right, so anode means positive, and cathode means negative. Let's just define them separately. Let's see cathode definition. Is a cathode positive or negative? In a device, the cathode is negative. Man, this is why things start to get confusing. Maybe we'll be very specific with our issue. How to wire an LED. LEDs have a positive and negative terminal. Okay, here we go. LEDs have a positive and negative terminal, also known as the anode and cathode. So positive is anode, negative is cathode. The cathode should be connected towards ground. Okay, that's all I need to know. The cathode should be connected towards ground. So cathode will be connected to ground. And we can kind of click and drag around to make it a little bit easier to see. There, and we've connected cathode to ground. And we generally do ground as black, so we'll change here to the wired color to black. And so we have a little bit more room. Let's move our our LED up. Move that wire out of the way, and now we can draw another wire which connects this side to here. And then we'll want to connect this side to pin 13. And hopefully, if we still have our code, which turns our LED built on, which is pin 13, and we'll actually change this up a little bit, and we'll make this 13 so it's a little bit easier to read. Maybe we'll call this int our first LED, and we'll put it on 13. We'll copy that into here, here, and here, and we should see our LED. I hope y'all can see that. It's kind of subtle, but our LED is lighting up. And so hopefully this all makes sense up to this point. I think we're about to hopefully have a little magical moment. We get to connect up to 14 different things along here. So, say we want to move this wire to pin 12. So we'll connect it to 12 instead. If we run our code now, you'll see that our onboard LED is still blinking up, but we want this LED to blink up. And so this pin now, this 13, refers to this 13 on here. So what we have to do is we have to change that to 12. And we could start. And now we have an LED blinking. So, say we want to have another LED. We could come in here. I wonder if we can copy and paste components. You can. Cool. So what if we wanted to make like alternating, I'm going to go with orange and blue. Oh, that's a bad orange. Oh well. Okay. This box is kind of in the way. Let's close our code out. Cool. So we connect this here, and we connect another resistor, and I think we can actually click. Oh, that's kind of, okay. We'll drag our wires. We'll drag this out. we'll want to connect this side to ground as well. Maybe so this is less confusing, we'll wrap it around. And then we'll connect this side to pin 11. And so first we can see, I'll show that we can connect two things to pin 12, and if we run that, we can see that both of them blink just fine. Now what if we wanted to, if we wanted to have them alternate? We could come back to our code, and we could say that we'll set up our second LED. And we can put that on pin 11. And this one, we could say, and instead of being high, we'll set that to low. And just so this is kind of a little bit more legible, we'll break this out. Okay, so first step, we'll turn one LED on, the other one off, and then we'll alternate. And so if we start this, we'll see that they go back and forth, turning on. Cool. And so here we can kind of expand things even further outward. Just make this black so it's easy to see. Maybe we'll make these connections blue so we can, or we'll make them orange. So the orange wires go to the orange LEDs. The blue wires go to the blue LEDs. And then the black ones go to ground. So this is starting to get a little bit chaotic. And maybe we don't just want to have these wires and these LEDs and these things all over our desks. So we can put them on something called a breadboard. So we switch over to desk real quick. This is a breadboard. And this is like a little place where you can begin to build out your circuits. And we will connect everything to this in a second, but I just want to bring us back to the screen so we can kind of learn about what a breadboard is. And I think Tinkercad actually does a really good job of this. So we can scroll down our list, or we can search for breadboard. So we found a breadboard small, and it looks like we also have smaller breadboards and larger breadboards. And so we're just going to grab the regular breadboard. So this is a breadboard. And I actually love that it hovers and gives you this kind of effect. So this is a bit of a mental kind of leap as well, because that circuit that we'd drawn out here, we had talked about how it kind of loops back up like this, like that, where this side would also kind of loop back up. And so it's kind of a very clear sequence of steps. One side of one thing is connected to the other side of the other thing, and then it keeps going. And it's a bit of a mental jump here, and please ask me questions if I don't explain this well. But basically the way the breadboard works is, it's also kind of annoying that it's rotated at 90 degrees, so you'd have to turn your head, but we can see that these 5 are connected. So they're all together. So if I put a wire in here and here, and then I connect a wire from here to here, these 2 wires are actually connected because they both share this same row. And so if we connected another wire over here, and another wire over here, and one more back down, these are actually connected in a circle. This might actually be a good exercise. So each row of 5 is connected. So anything that is connected into the row will also be connected to everything else in that row. Rows are not connected to other rows. And sorry, I'm talking about this kind of at 90 degrees. So if you rotate your head, you have row 1, row 2, and then you have columns A, B, C, D, and E. And on the other side, we have this second section of rows, and these are not connected to anything. Or these are connected to themselves, but not to each other. And you can see how these are segmented up. And then along the side, we have our, these are called our power rails. And 5 volts, we can plug into the plus side, and ground we can plug into the negative side. And these are all connected, and these are all connected. But you can see that they're not highlighting on the other side. And so those are all connected, and these are all connected, but they're not connected to each other. So breadboards come in different orientations, but that's how this one works, and luckily we have this lovely little layout. If we drag in this smaller breadboard, we can see this one in comparison just has rows, but no power rails. Let's see what this larger one does. So this larger one, you can see how things are connected, kind of similar to the smaller breadboard. But let's get back to this bit here. Okay, sorry about this. Okay, so if we start here, we can see that this goes two different ways. These are all connected, so if we wanted to create a loop, we could go up and around this way, or we can create a loop going from here to here. So if we follow this across, we get to here, and this whole row is connected. And it's kind of hard to see, but this wire only connects here and here. You can kind of see where the green shadowing of the border of this wire ends. So this goes from here to here, and then from here we can see it's connected to this one. So these two are connected together along this line. And then we can follow this wire up and over, and this kind of part gets easy. It goes up and over and down and then back. And this goes over to here, and then we've now got a loop. And so that's how we can begin to connect wires and things on our breadboard. So if we wanted to connect these wires onto the breadboard, we're going to switch over to our desk. All right, so we have our breadboard. We're going to go and look in our resistors, and I'm going to see if I can't find 220. That's 330. I was playing around with this kit before, so I think I might have bunched up all the 220. Yeah, so these are all 220. We can see that it reads 220R on there. And in our little circuit, we have two resistors. So we will grab two out of this mess that I made. And we'll want, let's see what we want. We'll want 1, 2, 3, 4, I can't count. How many wires? 1, 2, 3, 4, 5, 6 wires. So 2 yellow, 2 blue, or sorry, 2 orange, 2 blue, 2 black. So we'll grab 2 orange. The blues are a bit long, so I'll grab some shorter wires. The color doesn't actually matter, it's just a way to keep things organized. And then, is there black in here? I don't think so. We'll grab some reds, just so we have 6 wires to kind of distinguish. Okay, and then we will want 2 LEDs, which I put somewhere. There they are. Okay. So here are our LEDs. Let's grab a red one. Let's grab a green one. Actually, I'm going to grab a blue one. Okay. So this is what we want to connect up, and then we want to connect it to the Arduino. So if we look at what we have and what we've done, we have a wire coming from 11 to the resistor. So we will take a wire on the Arduino from 11 and connect it to the breadboard. And then along the same row, we will connect one of the resistors. And then we will connect the other side of the resistor to a different row. And the reason we do that, if we come back to the screen, if we had put, a resistor and connected it on both sides, this resistor's both sides are actually connected to each other. And this is actually kind of, it doesn't do anything. Whereas if you want both sides of the resistor to be connected, or to form like a circuit, you'd want to go across different rows, because these rows are different. Whereas putting it here, so the electricity when it comes in like this, so imagine the electricity is coming in from somewhere else, and we don't really know where that is. Comes in here, this whole row is connected, so the electricity flows in here, flows over to here, sees this resistor, flows across here, flows over to this whole side, and then will flow up here. Whereas if we just did this, so notice different rows. So the electricity will flow in here, and then it'll flow to both sides of the resistor, and you can think of a resistor as it resists. And so if we look in here, imagine you're offered if water was given two paths, one path through a hose that was very narrowly clamped, and one path through a hose that was wide open, the water would all go through the path that was wide open. So this is basically what's happening here, is the electricity can either go along the entire row and bypass the resistor, or it can go through the resistor, and it'd rather go through the resistor. Whereas if we bring it across, the electricity is forced into the resistor. There's no other way. I mean, it could go up into the air, but air has a high resistance. So the electricity is going to be more compelled to go through the resistor here. So that's what we're going to continue on with the desk. Let the webcam focus. There we go, perfect. And so we will connect one LED. And so if you'll notice, one side of the LED is longer than the other, and the longer side is the positive side, and I know that from experience, but something to know. So we plug the positive side in there. All right, and then we'll want to have the other side of the LED will go to ground. So we will connect that to the other side of the LED. If it'll get in there. And connect that to ground. And so this whole column, this ground column, is not actually connected to anything until we bring it back to the Arduino. So we'll plug in one more wire to the negative side, and we'll plug that into the ground on the Arduino. And we've now created ourselves a full little circuit. So the signal, the code that we're going to write is going to turn on this pin that we have here on the orange line. It's going to go over here. It's going to connect with the resistor. It's going to go over the resistor. It's going to connect to one side of the LED. It's going to turn the LED on. Electricity is going to flow through the LED to turn it on, come out the other side, and that wire is going to go down to the negative side, travel along this rail, negative rail, and then go back to the ground on the Arduino. That was me just eye checking, because sometimes I'm a little bit off with plugging pins into the right places. So if your sketch or your circuit fails, go back and make sure that everything's wired correctly. So if we come back to the screen and desk, and we're going to go over and we're going to take our code that we wrote here, copy it, bring it over to the Arduino, paste it in, hit upload. Need to save before you can send it off. It's compiling, and it's sent, and the LED does nothing. Oh, it does. That is not bright at all. I wonder if you can barely see that. But it's blinking. Cool. So we wired up one of the LEDs. So I did a little no-no. So I'm actually your Arduino should always be disconnected when you are wiring it up. So I disconnected it. And now we want to connect the other LED. So the other LED is going to come from this LED is wired up to pin 11. And in our code, we had wired up another LED to pin 12. So we'll do that. We'll drop a wire in here to pin 12. We'll grab another spot on the breadboard. Doesn't really matter where you do your things in the breadboard. I'll drop it in there. We will As we talked about earlier, it doesn't actually matter which goes first, the LED or the resistor. You want them together because you need the. So an LED can only handle so much electricity. And so this is one of the things you might actually find in terms of safety. LEDs can only handle so much electricity, so you always want to use a 220 ohm resistor to kind of limit the amount of power going through the LED. Because if it gets too much, it kind of heats up and it'll burn out. I've seen them kind of crackle or pop. It's not the worst thing in the world. Even I can demo it now, actually. But I'm going to put on my glasses for that. Should have my glasses on anyway. Safety first. Okay. So we come over here. Well, actually, we'll just demo this real quick. So you can run an LED directly between 5 volts and ground. Actually, let's unplug this before we do it. So I'll plug one side into 5 volts, the other side into ground. So if we watch this LED, it's going to turn on and then immediately pop and burn out. That was it. It's already over. And that LED is now useless. And it's burned out. I can even smell it. But yeah, so always use resistors, 220 resistors with your LEDs. All right, so let's finish wiring this up. We had run the red wire to the positive side of the LED, and then we'll want to run a resistor through from the other side of the LED. So we got that connected there, and then we'll want to run this with one more yellow wire to ground, and then our circuit should be complete. Cool. So red wire coming over the LED to one side of the LED, the other side of the LED is going to a different row. That's connected to a resistor in the same row. That goes up and over to the yellow wire, and the yellow wire goes to ground, and we already connected ground to the Arduino, so we don't need to do anything else. So now we should be able to turn this on, and we'll watch the alternating colors of the two. So red and then blue, and red and blue. And now we've just moved our circuit over from Tinkercad onto the breadboard. The breadboard, so there's, well, first, if there are any questions, please throw them in chat. But I will say, as I'm just going to kind of do a quick exercise of rearranging the breadboard, there's kind of an art to how you can do things on the breadboard. So this will come with time. So right now I have a whole chaos of wires, but I can actually simplify this a lot. So if you have any questions, throw them in chat. I'll answer as I'm doing this, but you can just kind of watch as I go. So we'll disconnect. So what we can do is resistors can act as kind of like, I mean, they are wires. On either side they have wires. So we don't need this yellow wire. We could actually plug one side of the resistor straight into ground. So if we get rid of this wire and get rid of that wire, put them out here, we can just take one side of the resistor, plug it into ground, and now we've just removed one wire from that little setup, and we can repeat kind of the symmetrical thing. We repeat that process. And now we've just cleaned up things, and we've condensed it down so we can plug more things into our circuit. So much less space, so much cleaner. Looks like I didn't wire up this LED properly, so let's see what I did. So the orange line comes into one side of the LED. Interesting. The other side goes to the resistor. So I should be able to plug that in. Okay, it looks like I just had a loose connection, so I push things down in, and we are good to go. Cool. Awesome, 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 awesome. So it looks like there are no questions. Take a quick drink. let's come back to day 2. We made an LED blink. All right, so our last task of the day, we're not going to push a button, we're going to make a night light. Changing it up, changing it real quick. We're going to learn about night lights. So, we got about 25 minutes left, so we'll see how far we can get with this project, and then we will close out for the day. All right, so let's close down all our links. Okay, so, close Tinkercad. So the next thing we're going to learn about is called a photoresistor. I believe it is in here. Yep. So we're going to learn about this component. So we go to Google. Or, sorry, Arduino Photoresistor tutorial. So I prefer, when possible, to do Arduino tutorials, officially from their website. So I'm going to grab this one. So it looks like the components we need will be a breadboard, an Arduino, 100 ohm resistor, a photoresistor, jumper wires, and an LED. And actually, we don't want to learn about all these things. We want to learn about just a photoresistor. So that might be too much. Let's see if this has what we want. Maybe not. So I know from experience which tutorials are helpful. Let's see. Okay, this looks, I didn't want to set up an LED, and so this feels a little bit better. So the okay. So we'll jump in, and this is kind of just giving you a brief overview about how I learn about new components. So the photoresistor is an electronic component which has variable resistance. So we learned about resistors, and this just is variable resistance, and it changes according to the amount of light received. So the resistance decreases when exposed to the light. Talks about what it's made of, blah, blah, but we don't really, we're more interested in kind of the code. So here's the code. In the setup, we begin with the serial monitor. And so we covered the serial monitor yesterday. The serial monitor is a way to kind of send and receive bits of data, send to the Arduino and receive from the Arduino. So if you set up like a temperature sensor and you want to like debug it, you can have it output to the serial monitor. So before we go into that, we'll do a little brief preview of the serial monitor. Whoops, I want an Arduino. Cool, so we drag this in. I don't want to. Okay, so we'll come over to code, go to text. All right. So we'll copy what they had with the serial.begin. And if we just want a serial.print a message, and if we start our simulation, we come down to the bottom and click on serial monitor, and we get hello. For those that are following along with Arduino, we can copy this code, go into the Arduino, can upload it here. It's done uploading the Arduino. We can now go over to serial monitor, and we see hello come out. So same functionality. And then you can actually have it keep looping things. So if we wanted to loop some number 0, print it out, and then increase it by 1, and then want to delay so it's not spamming too much because the loop happens very quick. We can see that we now have a little thing that can print out data, and you can even actually chart the data. So maybe we wanted to see what the chart of this looks like. If we clear this out and then print, you can see that we end up getting a chart of the data. So if you're using numbers, you can actually use the serial plotter, which is also in Arduino, serial platter. So that's serial. And we're going to use that to kind of set up and learn about the photoresistor. Okay. Cool. So we'll want to read in the value of the photoresistor. So in our loop, we'll want to do int value. And then we will write that value out to the serial monitor. And then it looks like kind of this similarly, they'll print out the value, they'll delay by 250 milliseconds. Cool, so that's the code. And how is it wired up? So it looks like, what does it say? The first pin goes to 5 volts. Okay, so if I pull out my Arduino and I look at the Arduino, 1, 2, 3, 4 pins, because this image is very hard to see for me as well. 4 pins down on the Arduino, 1, 2, 3, 4 is ground. So we'll need a wire there, is what it looks like. Oh, I can't terminate this wire without connecting it to anything. Great. That's annoying. Go away. All right, I've done it. Oh gosh, what is happening? Just delete yourself. I can't delete it. Uh-oh. All right, let's get out of Tinkercad, actually. I just copied the code to the Arduino. Okay. So 4 pins down is ground. So let's we'll switch over to screen and desk. Take our resistors and put them back in our little bundle with our other resistors. Always good to kind of keep your space clean. I'm going to take my LEDs, put them back in the bag. Kind of just throw the wires away. Okay, so it was pin 4 down was ground, so we'll bring ground in, connect that to our board. And then, man, I wish I'd given a better, let's see if we can zoom in on this thing. Okay, still blurry, but at least we can kind of see where these wires are going now. So this ground wire comes in, and we can see that this symbol here is the resistor, and then over here we have the photoresistor, and then we have some other wires which connected on the other side. So we will connect this resistor, and he set a resistor value of 10 kilo ohms, so 10K ohms. So I'm going to go into my little collection and find 10K, which is what we got here. So we'll grab one of the 10Ks off, and we'll connect that to one side to ground. I'm going to try and keep in mind how I want to evolve this circuit over time. I want to add some LEDs at some point, make a nightlight, so leave some space. So I can do some other stuff elsewhere. So I'll try and keep in mind where I'm placing things as I go. All right, so the LED is, or sorry, the resistor's on there, and the resistor connects to the photoresistor. And a photoresistor looks kind of similar to a resistor. It's got like a circular thing on top, and that's where the light hits. And so it looks like that connects to the same row as the other side of the resistor. So I'm just going to move the resistor over a little bit so I can make room. Okay. Plug that in there. Cool, so now we have our photoresistor in line with the resistor, and the last bit it looks like is we have this green line that is also in the same row as the other two, and that goes down to this pin over here, which if I look at my Arduino is A0, analog 0. So I will connect a wire from A0 to that same row. This wire is a little short, and my kit has longer wires, so I'm going to grab a longer wire. So A0, connect to the same row. Perfect. And then the other side of the photoresistor is connected to this red wire, which goes to 1, 2, 3, 4, 5 down on the Arduino. Just 1, 2, 3, 4, 5 is 5 volts. So we will grab another long wire from 5 volts. and connect that to the other side of the photoresistor. Cool. So now we have our circuit wired up. Now we can stop looking at this blurry image. Okay, so here's our code. Let's copy it to here. Let's upload it and see what happens. Done uploading. So we'll check our serial monitor. And we are outputting 775. Okay. What do I do with that information? That's it. So let's see. Let's go back to the description. The photoresistor is an electronic component which sensitivity varies according to the amount of light received. So what if we decrease the amount of light? So if we cover it up, we see that actually the values are dropping. I wonder if we put our finger right over it, it drops down to as low as 440. If I instead turn on my phone's flashlight, shine that over, we can see that it gets a lot higher. Cool. All right. So we notice that we now have this circuit here that can measure the amount of intensity of light in the room. And so now we have our initial kind of our trigger for our nightlight. So a nightlight needs two things. It needs to measure the amount of light in the room, and if it's below a certain threshold, do something with that information. And so maybe we think of as my finger covering this as our threshold. So if the value gets below maybe say 500, we will turn on a nightlight. So we'll use some LEDs for nightlights. So we have what we just constructed with our LEDs before, and we could kind of use that same code, that same idea, merge it together with this code, and we can get ourselves an LED nightlight. So we recall that for LEDs to work, we need 220 resistors. So I will grab a 220 resistor. I will grab a blue LED. And we'll need some wires. So bring our wires back in. So we'll connect our LED to a different pin. So maybe we'll put it on pin 12. Connect that to our breadboard. Connect our LED. Connect our resistor. Cool. So that should be what we need for that. I like to test these things kind of in isolation before I put them together. So we have this sketch, and we'll make a new sketch for our LED. And so our LED, we will have nightlight pin will be 12. And we'll set up our nightlight pin as an output. And then we will digital write nightlight pin on, just to make sure that we wired everything up correctly. So we'll upload that. Gotta save it. Okay, so it doesn't turn on. All right, let's see what we did wrong. Okay, so it looks like accidentally I connected it to pin 13 and not 12, so I'll move it down one, and cool. We see that our LED turns on. All right, so now we have a functioning. So now we can upload these codes, or these lines of code independently, and they won't work together, but everything on the breadboard is wired up for them to work. So now we just need to get the code from each half together. And so for that, I like to also create a new place. 'Cause it's always good to have little environments that you know work. So I know this left window and this right window both work. So we'll use this side as a starting value or starting code. So we'll copy it over and we'll paste it in to our final sketch. And since we don't need the right side anymore, we'll just leave that behind there. And so we'll want to copy the int. And then we'll want to copy our pin mode and put that in setup. And now we actually need to write some code to kind of hook the two together. So, actually want to leave delay. So we had said that our threshold for turning on the night light, it would be 450. So we'll call that maybe our night, we'll call it our light threshold. We'll set that to, or we said 500. And so we don't need this anymore. So we're going to compare this value and see if this value is less than our light threshold. And if it is, we will want to turn our night light on. Alternatively, if our light drops below that threshold, we'll want to turn it off. All right, so we will upload that, and we'll see how that goes. All right, so it looks like the code is uploaded. And if we come over here and put our finger here, light turns on, take it away, light turns off, and we've now made a night light. Awesome. Any questions on that? Cool. So I will take this code and I will copy it to Slack. Minimize this all out. We'll jump back to our presentation. So that ends the first part of today on circuits. If you like what you're watching, please toss me a follow here on Twitch. Much appreciate it. Trying to get 50 followers by the end of the week so that I may unlock some new things that'll help me stream better. Additionally, ask for your feedback in a little survey. You can find the survey link down below in the About section, as well as all the resources for this presentation, link to this presentation, link to the website, all that good stuff. Let's connect and chat in the future. I have social media down below. Would love to see what you're working on Instagram, on Twitter, on Hackaday, things like that. So feel free to connect with me there. So up next, to close out, if you want to find yourself some homework to do between now and the next session, which begins in about 2 hours, we'll have homework. So join on Slack. Again, link in the About section. Google your questions. So we did a little bit of Googling today. If you struggle, please feel free to help, or feel free to ask, and we can have lovely conversations in Slack. So, if there are no further questions, thoughts, whatever, I will hold for a quick second, and then we will get into the homework. Hellcat says thanks. Thank you for attending. I appreciate you being here with me today. Cool. So, 2 problems. First one is kind of similar to what we did today, but slightly different. Your task will be to connect a push button so that pressing it turns on the LED on and off. So if you got one of these intro kits that I had mentioned that is currently scattered all over my desk, there are push buttons in there. They're in this little bag. Otherwise, you should be able to find them in Tinkercad. Hopefully the push button is actually in here. I did not check if it was. Let's see. Push button. Yes, cool. So you can wire up push buttons. So that'll get you learning about how to use push buttons and Google them and things like that. And then how to just, basically the goal is press the push button once, the LED turns on, you press the push button again, the LED turns off. So there's some bit there. And similarly, problem 2, pick one of the components either in Tinkercad or that you have in your kit, go to Google to learn about it, and then use it in a circuit. So So those are the 2 tasks for today. If you need help choosing a component for problem number 2, feel free to post in Slack. I'll keep an eye on it. I'll be around. Otherwise, I will see y'all again in 2 hours. Cool. Thank you for joining me. And I will see you then.